Braces are usually diagonal members that can carry both tension and compression forces. Braces mainly withstand lateral, or in other words horizontal loads, such as wind hitting the wall of a building. Braces help to increase stability in a structure and serve as a secondary support, which is termed auxiliary support. Like beams and columns, we draw braces using straight lines. The lines in yellow are the braces. We will now examine how braces resist forces. If there is a force applied from the top left, the brace highlighted in purple will be compressed, and the other brace highlighted in blue will be in tension. If a force was applied from the top right, then the brace highlighted in blue will be in compression, and the brace highlighted in purple will be in tension correspondingly. When braces are carrying a force, one brace will be in compression while the other will be in tension. Pause the video here and see if you can identify where the braces are in the structure. Here are the braces outlined in purple. Now, assume a wind force was hitting the building from the top left. If there were not any braces and the load was strong enough, the building will collapse to the right. Since there are braces, the brace colored in blue will be in compression, and the brace colored in green will be in tension to prevent the building from falling. There are different kinds of structural framing, and we will look at two types. Trusses carry forces in both tension and compression. They do not carry moments or allow bending to be transferred from member to member, since the connections are pin joints. Recall that pin joints carry movement in the X and Y direction but do not carry moments. It should also be noted that trusses are mostly made up of triangles. When we show forces being applied to a truss, typically they are only applied at the joints. They are drawn with straight lines as the individual members and pin joints as circles for the connections. I have drawn an example here with yellow lines as the members and green circles as the pin joints. If we assume there are forces acting vertically downwards at the joints of a truss, the forces will be distributed downwards until they reach the bottom members, which then distribute the forces outwards. I have shown the direction of the forces with blue arrows here. This is an example of a truss in real life. See if you can determine which part is the truss. I have outlined the truss in purple. Assume there is a force acting perpendicular to the joints of the truss. See if you can draw in the force arrows. There are forces in both tension and compression here. The forces will be distributed in the direction of the green arrows I have drawn. Frames are different from trusses because they have full moment connections, which means that they do transfer bending and moments from member to member. Recall that a full moment connection is a stiff connection and does carry moment. Loads can be applied along the members and not only the joints, because the members can carry forces by bending as well. They are drawn with straight lines as the individual members, but without pin joints for the connections. I have drawn an example of a frame with straight members in yellow here. We will now draw a frame and assume a force is applied vertically downwards at the top. The beam on the top is carrying the load by bending, which I have shown with green arrows. The beam then passes the force to the columns that carry the force through compression, which I have drawn in purple. This goes back to the beams and columns that we learned about earlier. To avoid confusion, the arrows I have drawn mostly represent how the load path is distributed, and do not represent how the forces are being carried by the members. Pause the video and see if you can determine how this door frame would distribute a load, using the information provided in the previous slide. We will assume there is a vertical downwards point force acting at the middle of the door frame. The beam along the top would distribute the force outwards by bending. It would then pass the force to the two columns on either side, which carry the load by compression, and distribute the force eventually into the ground. Follow the direction of the blue arrows I have drawn for a visual representation of the load path through the frame.